All right, everybody, let's talk a little bit about databases. So, databases are quite a bit more difficult of a topic than, let's say, Word, Excel, PowerPoint, other Microsoft applications. In fact, there are literally, several different classes you can take, books upon books you can read on database design and how to build databases properly. Because it's not quite as simple as just clicking make a new file and then putting some stuff in. In Word, anybody can write a Word document. You might need a little help with formatting and stuff like that, but that can be kind of quickly learned. Databases are a whole another topic altogether. So we're going to get a little bit into what databases are, what they're used for, how we make them. So first and foremost, let's say databases are everywhere, literally everywhere. You'll find your personal information, where you live, how old you are, what your name is, birth date, all that good stuff, probably in at least 100 different databases. Do you have well, if you're going to college, obviously you're going to be in our database. Do you go to a store? Do you have credit cards? Those are databases. Do you pay bills? Well, they have a database with your information in it. No matter how off the grid you try to be, your name is going to be somewhere in some database. Social security number, well, that's going to be in a database somewhere. Now, what a database is it's used to store information, so we can search for it. You always hear about all of these breaches, like Target or Walmart or whatever had their security breach, and a whole bunch of credit card information and user data was basically stolen. And if you have enough information, you can do things like guess passwords, break into other people's accounts and things like that, or even get their credit card information and start emptying out their bank account or maxing out their credit cards. Information is worth a lot of money. And this is one of the reasons there are so many databases out there. Even things you don't even know about for the most part. Spyware, for example, is very big. The whole purpose behind spyware is to steal information and sell it. So you may have heard of spyware. There are special scanners you can get to get rid of it. But basically, in its initial stages, it was basically just pop-ups. Pop-up ads, they pop up, you accidentally click on them, or it makes you go to them automatically and they get a couple of cents. Now it's a lot more intrusive. It will sit on your computer and basically just keep track of everywhere you go, and that information is sent back to some server somewhere. And that company sells that information to advertisers and stores and other things. Because if you think about it, if I have information, I can use that information to make a lot of money. So let me explain how. Let's take Facebook, for example. Huge, huge database. Think about what you write on there, or what you put on there. You have your birth date, your name, who all your friends are, who your family is. They even have little options to say if this is your sister, your mother, your brother, and all that. Facebook knows who that is. Now, for years, they always said, "No, we don't do anything with your personal data. It's locked in the vault." And a couple of years ago, they were pretty much pointed out by security experts by that's an outright lie, and they agreed. Yeah, we've totally been selling your information for years for millions upon millions of dollars, and they have. But think about that from an advertiser standpoint. If I want to open a store in a certain place, and I had access to a database where I can see, what places all these people that live in that area go to, what they like on Facebook, who their friends are, what their friends like. I can save myself a ton of money if I know where everybody's going. I can put my store there. Or if I know what products everyone is interested in, I can sell that. If I'm selling My Little Ponies, t-shirts or something, and no one's interested in it, I'm going to be wasting my money. But if I go through a huge database of information that someone has created, I might pay them, few hundred, $1,000, whatever. I basically know what everyone wants. No one wants My Little Pony, maybe a few people. Everyone wants, this other thing. transformers. I don't know. Depends on the location, the area. I know what to sell because I know what everybody's interested in. If you ever like gone to Google or Facebook or something and you were chatting with somebody about something, and then instantly you see advertisements for the very thing you're talking about pop up, well, that's because, well, one, it's not necessarily database related. They will keep track of things like that, so they can pop up ads that are closer to your preferences. Some of that is just they have programs that scan through all your text and emails and messages, and they try to tailor those ads for you. Because if you think about it, if they know what you like, if you're interested in fitness, for example, and a bunch of equipment, training equipment pops up, you're more likely to click on that than My Little Pony. If you're not interested in that, you're not going to click on that ad. That's effectively what they're trying to do, and it can save them a ton of money. That's what spyware and a lot of this information gathering is for. Now, other places use it to just keep track of information. Let's take the DMV, for example. The DMV, everyone who drives has a driver's license, and on that is a driver's license number. Now, of course, that's your name, your address, and they also tie in to, police records, whether you've got traffic tickets or things like that, right? That's a huge database. Is your license expired? When does it expire? It keeps track of your picture and your addresses and a whole bunch of other stuff. You're paying bills. Well, they got to know how much you owe, so they can call and tell you to pay them or break your knees. I guess it depends on how shady of a person you're borrowing money from or owing money to. But all that is done with databases. And like I said, databases are embedded basically everywhere in society. You're not going to get away from them. And just having that information can be insanely useful. This is why so many people try to hack into companies and get into their database systems. Not so they can see how nicely built they are, but so they can see what information they can gather. Let's take Target, for example. And I think I've heard a similar story with Kroger, actually. But they both have these cards you can get, like a Target card or a Kroger card. And every time you buy stuff, they might give you a discount or something like that. They'll send you coupons. Based on what you're buying, they'll keep track of it. I know Kroger specifically does this. You'll buy bread, you'll buy milk, you'll buy various, like a frozen pizza or something, and they'll send you coupons for stuff that you buy, and they'll send you coupons for stuff that you haven't bought before, but they think you would probably buy if it was a little cheaper. So they'll give you a coupon to try to get you hooked on something else. Now, just to give you an idea of how powerful this information can be, this guy here, a PhD candidate, wrote a little article about something that happened at Target. And again, I heard something similar from Kroger too. Basically what happens was, their data mining campaign was a little too successful, a little too good at predicting things. So they had this little campaign where they tried to predict if somebody was pregnant or not based on their buying stuff. They did a lot of mathematics and cross-checked everything that they bought and various things like that. And then they would send them, diaper coupons and bottle coupons and things like that whenever they suspected they might be pregnant. Well, this guy, had a teenage daughter, a son, dog, wife, the whole thing. Started getting coupons in the mail, and they were addressed to his daughter. And he opened the coupons, and they were all baby stuff, diapers, bottles, and he's like, what in the world is this? Why are they sending this to my daughter? Turns out she was pregnant. They knew it before he did it, actually. And I think they may have even known it before she did, actually, based on the things that she was buying and, all that stuff. Just with a little bit of information, they were able to predict that she's going to have a baby. Obviously, the dad was not too thrilled about this, but you can kind of guess. If you have enough information, you can kind of draw, ideas of what someone's going to buy, what their situation is. If someone buys the cheapest cereal that they can get, they don't want to spend a lot of money. They're not going to be interested in a premium top shelf, item that's kind of expensive. Someone buys a bunch of electronics, well, they're probably going to be more interested in various electronics. You can send them coupons and stuff about that. So all databases are, well, one, they're used to store information. Two, they're used to search information. And that search can be as benign as just, here's your bill, you want to pay it? Okay, poop, bill paid. Or as, horrendously terrible as they're selling all that information to, target you or to gather money or to break into your bank accounts and various things like that. Because just imagine security questions and how many websites you probably use the same password on. If you use the same password on everything, that's honestly the worst thing you can do. Just as a side note, some uh, websites do what's called two-factor authentication. Basically, you log in, and if it's not from your computer, then it'll message your phone, and you have to put in a code. That's generally leaps and bounds safer than not having that, and you should totally do that because it doesn't take much for somebody to break into your account and just change all the passwords and take it from you. So, databases. Now, again, we're going to learn the basics of how to make it a database basically here. A database, simply put, is several tables of information. Now, these tables of information can be anything. If I'm talking about, let's say, I'm trying to find oh, there we go, a better picture of some sort. It'll keep track of IDs and names and dates, how much people have sold, that sort of thing, how many hours somebody's worked. It can do some basic calculations. It's not really the calculator that is Excel, but it can do some basic things like factoring in how much money you've made this month or what your salary is, some simple math stuff. So I can put in all my hours, my names, and I can keep track of that, and I can even search over the course of months or years how much I made each month or how much I've made to date. It's got a whole lot of useful things you can actually put together. Now, of course, if we talk about the airline industry, for example, this is a pretty good example of a database. And I made a very simple database here to kind of show you, but let's think of anyone who's ever flown an airplane, for example. What do? You get a ticket, and you're flying from one city to the other, right? Now, generally your ticket has a flight number. The destination, where you're coming from, your arrival time, your departure time, what plane you're on, that sort of thing. This would be a table in a database. And of course, they would have tables, that listed their airplanes and information. They'd have tables for their employees and how many hours they're working and how much they make. They would have tables on the individual passengers, where their address is and what bags they checked and things like that. This would probably have several different tables. I made a very simple one with 3, just to kind of give you an idea. But that's roughly how a database works. Now, what I'm actually currently in here is Access. You may not be able to see all of it here, but this is the software we're going to be using. And we'll get more into how to make that later, but this just has 3 tables in it. And I'll just explain kind of the parts and pieces here. This is one table. And you see I have 3 different tables. A table is just a group of related information. So in this case, this table would have all the airplane information in it. This table would have all the passenger information in it. And it would just be about passengers. This one would have all the different flights. This would be kind of what you would see if you were looking at that flight board about all the airplanes that are about to take off and that are landing and stuff. You'll be pulling from that database. So if you notice, I've got a whole bunch of little things here in this. So let's go through a couple of little terms here. This whole thing is called a table, and it might look a little something like this here. It had several rows, several columns, that sort of thing. Now each row is called a record. So just some terms you'll hear in the book. A record is just one row. If we use Northwest for an example. College. You are in the database. And we probably have a student database where it has your name, your ID, your address, all of your personal information. Now in that row, that record will only be you. We're not going to have other people's, stuff in your row, hopefully. We go to another row, and that's another person, another person. So each one of these is just a record. Now all of these records together make a table. Now one item here is what's called a field. So if I click here, this is the flight number field, where I can put one individual item. This is the destination field. So a field is just one piece of information. Now, you may notice in this picture, let's go back to one of these other things. This will be fine. That I've got flight number, destination, source. This is what my table would look like, and it would be a lot longer if I filled it out. But let's look at it at another view. This is actually called the datasheet view. This is the design view. This is typically where I go when I'm creating databases. Eventually, you're going to have to go here anyway, regardless. You can actually add fields and do it here, but I don't really personally like that. You can come up here and change what type of information it is. There's one of the big things about Access is there's a whole bunch of little ticky things that it can get grumpy about that you have to do specifically for it to work. Excel, you can kind of just type stuff in and it assumes, and usually assumes correctly. Access, you have to be very specific about what everything is, which is one reason it's a lot harder. Let's take this for example. This is the structure of this table. You see I've got flight number, destination, source, arrival time, departure time, and a plane ID here, which is what plane I'm on. Very simple, doesn't have as many fields as it probably does normally, but you kind of get the idea, I hope. Now, when I'm creating the table, I come here and I decide what fields I need to represent this. In this case, these are the fields I decided. Now, if you notice, one of them has a little key next to it, and the others don't. This key is what's called a primary key. And a primary key is something that uniquely identifies each record. So in this case, there's only going to be one flight number that matches this. There'll be another flight number that matches another flight. There'll be another flight number that matches another, and so on and so forth. Each airplane will have its own unique ID. Usually you'll see it like on the tail. No two planes are going to have the exact same ID. So this ID uniquely identifies that plane. Each passenger will probably either get their own ID, or you could use their social security number or something along the lines of that. Now, if we look back at our DMV example, what do you think the primary key there would be? Probably the driver's license number, right? Now, previously it used to be your social security number, which would be your primary ID in most databases, honestly, because no one's going to have your same social security number, hopefully. It's going to be unique to just you. Driver's license number is the same. Now, why do you think driver's license number is no longer social security number? It used to be back in the day. Well, they changed it because, well, if you lost your license and someone got it, now they have your social security number. And with that and any other information, your first name, last name, address, and all that stuff, they could go out and just set 20 credit cards in your name. And there's honestly not jack you can really do about it. They've got your information. You now have a bunch of credit cards in your name, and the credit card company will come to you and say, hey, you owe us $50,000. You have to set up a credit card. You can, of course, there are now avenues you can take to fight that if it was illegally done. But for years ago, there wasn't much you could do if that happened. I had a boss whose roommate stole her information, identity theft, and then I think she created 4 or 5 different credit card accounts, maxed them all out, and then ran off on her. And 10 years later, she was still fighting with, credit card companies about that debt. She's like, it's not my debt. My roommate stole my identity. But again, things have gotten a little better now because that's been so common that there are procedures in place to kind of help with that. But still, it's an expensive process and it sucks if you end up getting that happening. If that ends up happening to you, that sucks. So that's one of the reasons they changed that. Of course, if you lose your license, people can still get a lot of information from you. A lot of time they end up digging through trash. You'd be surprised at just what a few scraps of paper can give somebody. Now, as I was saying, the primary key uniquely identifies everybody. And for example, Northwest or any college, your primary key would be your student ID. I actually have a faculty ID that allows me to, uniquely identify myself as a faculty person, faculty member, advisor. Whereas students will get their own student ID, and that's what you use for generally everything. Now, usually your primary key here will be some sort of ID. It's almost always something like that. It could be a mix of letters and numbers. It could just be a couple of numbers or a couple of letters or whatever. Almost every database system uses some mix of that. Of course, you could use, let's say, a driver's license number or a social security number where it's all numbers. But generally, letters and numbers allow you for more flexibility, more combinations. Although when you think about it, even with this, there are 9 digits, right? Meaning, if you do just a little quick count, you can see there's, almost, what is it? We got 900,000, 900 million, about a billion different combinations. Last I checked, and this is per state because it's South Carolina and that's the driver's license number for that state. We won't have a billion people in every state. It's just not feasibly possible. So this pretty much works, even going into the future, even if we expand. Because some people will end up dying, and then those numbers will come back and be used for someone else. Now, if we have what's called a primary key, that's what this little key is for, and every table has to have a primary key, like that, flight number, passenger ID, primary key. The next thing would be what's called a foreign key. Now notice we have plain ID here, right? And plain ID is actually also in airplane. Notice it's the primary key there, right? As you can see, primary key. Now, it's in flight as well, but there's no star, there's no nothing next to it. When you have a primary key from one table and it just happens to be in another table, what that is called it's called a foreign key. Now, there's nothing you have to set for that. As long as it's primary here and you put it here, it's what's called a foreign key. And what that does is it allows you to connect databases, or connect tables, rather. I'm sorry. We're not going to be searching for much yet, but when we do go for searching, we try to query and actually search things. Click the right button. There we go. This allows you to do some things that you can't do normally. Oh, it's a little different. Let's see, flight, passengers, and airplane. All right. Now notice I got some lines here. And what these lines are called relationships. So if you notice flight number is here, it is also in this passenger table. Plane ID is here, it is also in this plane ID table. Now, the reason you have these little arrows is this plane ID is a foreign key. It's also a primary key here. I know that can be a little confusing, but as we go through it, you'll kind of understand. This is a primary key. It uniquely identifies a flight. And it's over here, but it's not the primary key. So it's called a foreign key. But it allows me to connect these tables together. So if I was looking at, let's say, a passenger and I got their information, I could see their flight number. And I can use that flight number to bounce over to this table and pull up their destination, their arrival time. I could even use this plane ID and bump over here and see what's, how many seats are on that plane, that sort of thing. So this allows me to go from one table to the other, basically. Now, if I don't have this connection, then it won't let me connect these two items. Like, I'll see your information. If flight number is not there, I can't tell what flight you're on. That makes sense. We'll just leave that up for now. Now, that's kind of the gist of it for how queries and stuff work. Now, back to those relationships. There are three kinds of relationships. There's one called many-to-many, and what this means is that basically, let's use the faculty-student example, because that's the easiest one. Let's say that I'm an advisor, and then there's a student that needs advising, right? In the database, if the student could go to any advisor they want to, it doesn't matter. And of course, I can have every single student to advise. It doesn't matter. This is what's called a many-to-many relationship. It's terrible setup for a database because it creates a lot of what's called redundancy. Now, redundancy just means I'm going to have the same thing in the table over and over and over again. In database design, I can't have the same thing over and over again. So if I put in 65 again, for example, Cessna 10, and I try to go on, it's going to give me an error. It's going to say that would create duplicate values. Primary key can only happen once. Now if I change this to 66, maybe I have two Cessnas that seat 10 people. These can repeat because they're not the primary key, but this one cannot. So for example, if we go back to the faculty advisor example, you have a student ID, no one else has your student ID. If I put, Bob Smith in there, right? If I was using Smith as the primary key, that means I can only have one Smith come into the college. I would be like, all right, what's your name? Smith. Oh, we already have a Smith there. I'm sorry. You're going to have to go somewhere else. That just wouldn't work. So you get an ID number. And we can have 50 Bob Smiths. And we differentiate them using their ID number. So this part here, even though it's the same, isn't what's called redundant. Redundant would be if I had the 65 here several times. When I went to search, I would get several different answers that all say the same thing. Or worst case, they say different things. Imagine if you were in a database for a credit card company 3 times. You called, you paid your bill, and they fixed one of those records but not the other. Suddenly in the mail, you get 2 bills because you're in the database 2 or 3 times. And you're like, I paid one. Well, according to our records, I see that you didn't pay. So that would be really confusing and really broken, which is why many-to-many just doesn't work. Now, one-to-many is actually how the advisor-student ratio works. Every student's going to have one advisor assigned to them for whatever your major is. For me, I do computer science, computer information systems. I can also advise business and a couple of others, but it's mostly the computer stuff that I advise. I have, probably hundreds of students I have to advise any given time. Every semester it ends up being somewhere between 50 something to 100-ish. A student's only going to have one advisor. So I have many students. The students have one advisor. They're only going to come see me, preferably. Whereas I may have 10 students in a day that I'm advising. So that's called one-to-many. Now in this case, I wouldn't have near as much redundancy. The redundancy would probably be if I was in like the student database, the advisor number would repeat because the advisor is advising multiple people. But in the other table, it would just, as far as the student is concerned, they would just see that one advisor. Now the last relationship is one-to-one. Now this is not completely, it's possible in some contexts, but not really so much in our advisor-student relationship. Because imagine if one advisor can only have one student and one student can only have one advisor. You're basically in a disciple situation where you only have one person that you deal with and they only have you. If we have 1,000 students, we would need 1,000 faculty to do that, which, again, not possible. But that is a one-to-one relationship. So those are the 3 different kinds of relationships. Now you may have noticed one other thing, and that is data type here. For data type, every time you create a field, whatever that has to be, you come over here and you have to decide what kind of information it's going to be. Short text, almost everything will be short text. There is also long text, which I'm going to pick something else to be long text. Normally it'll just be short text. And notice that there's this field size, 255 characters. More than likely, there's not going to be much that's going to be more than 255 characters long. I will probably come in here and, destination. Well, that's city, state. I would probably put that in different fields, but let's just say 20 or something, right? Or 40 even. I probably wouldn't have 255. I would set a specific size. I could even come in here and set a specific format depending on what it is. If it's date time, there are several different date times you can actually use. If we're talking about numbers and things like that, there are several different setups for numbers you can use. You can even format it so it uses a certain number of decimal places, that sort of thing. Now you may notice that there is a caption here as well. Caption is basically, notice it says flight number. I'll go to the caption and just write FL hashtag. And it'll ask me if I want to save. I'll go back. Yep, it's fine. It will give you a little warning saying, you made some changes. And if you make the wrong change, let's say flight number I change to a number. Long integer. That means it's got to be a whole number. 1, 2, 3, 4, 5, a million. If I change it to this, and then I try to go back, it'll pop up and say, you've changed the size, you could lose information in there. And if I change it to number, I will lose information in it. Nope. Here we go. And the reason for that is, boop, that's not a number. It's a text, FL56. If I change it to a number, that basically erases. And it's gone. I have to fill something else in. So you could potentially lose stuff. It just depends. Now, we've got short text, which will be almost like 90% of everything will be short text. One thing that confuses people is phone number. You see phone number. They immediately make it a number. Well, what does a phone number look like? Like that, right? That dash is not a number. If you put that in the phone number category and you set it to number, it's going to give you an error because that's not a number. That is a text. So almost everything ID will be, like primary keys will be IDs, phone numbers will be texts. Of course, times and dates will be time and date. Now, to know if something's a number, the easiest way is to ask yourself a simple question. Can I do math on this? Let's take plain ID, for example. I'll make it a short text. Yep. It is 65. Now, am I going to add up the plain ID 65 and another plain ID 66? No, because they're just IDs. So I wouldn't make that a number. Would it break something to make it a number? Probably not. But it should still be a text. And since there's only 2, I would make it, size 2. The reason I would make it 255 is because it kind of reserves that much space. You end up wasting a little bit of space. Now, for what we're doing here, a couple of simple tables, it really doesn't matter. But if you were doing thousands of tables, you would, start noticing a difference. Plus, the larger the field size, the more likely you are to screw something up. If, the field size only allows 10 letters or something, and I end up typing in 32, that probably means I messed something up. I typed 2 things into the same field or something, something along the lines of that. Most likely. But those are the different types. Short text, number. Now, we generally won't use long text or large number. A number would be anything up to, I think, 2 billion and something. A large number would be beyond that, typically. But we're not really going to go that big. Date and time would obviously be date and time. Currency is basically the same as number, except it has a $ sign and does a little rounding. Auto number is the default. Whenever you make a new table, it's set to an auto number, and that means that you can't change it until you get rid of auto number. Almost nothing we do will be an auto number. It just defaults to that. Auto number would be 1, 2, 3, 4. Every time you make a new record, it just automatically increments the number. It's kind of the cheap primary key if you don't really want to think about it and like have a format and stuff for it. Yes, no is exactly that. Yes or no. It's a little drop-down box that is yes or no. Pretty straightforward and simple. You can have attachments and fields. You can do calculations. You can have objects and other things in there. You kind of get the idea, I hope. But that's kind of roughly the overlay of how Access works, how databases work, what the point and purpose of them are. Now, if you have any questions or any issues, you can feel free to leave me some messages. If not, I guess I will see you in the next video.